The application of geophysical exploration in the study of the soil rock layer and shallow groundwater to support the community-based water management project of the Deputy Ministry of Education by Dr. Kanaya Sopon-Phanit. An appropriate geophysical survey method for the shallow groundwater is the resistivity measurement using the principle when the soil and rock layer are contained with water, the electrical resistance is lower than the hard rock layer. The survey principle is release the electricity into the ground underground, measure the electric current and measure the electric potential, and calculate the resistance by using the ohm formula, where the K is the geometry, the constant value of the survey position, when the voltage and current are measured. In geophysics exploration, it is necessary to study to the topography, where it's related to groundwater source from the terrain, the direction of the water flow from the higher and slope terrain flowing down to lower along water canal and flat area. The geophysics survey procedure to measure the resistivity data consisting of preparation, correction, and study the basic information, such as topographic area photo and satellite imagery from the Google Earth map. The data source consists of groundwater well information that can be searched on the website of Department Groundwater Resource. Knowing the geology and hydrogeology of the study area, it is useful for determining to suitable construction of the groundwater recharge pond. From the case study, the geologic map of Sa-Kaeo province was prepared by the Department of Mineral Resources in 2007. The study area and the nearby consists of sedimentary and metamorphic rock, consists of Quebec sandstone, shale limestone, and conglomeratic. From the groundwater potential map of Sa-Kaeo, Department of Mineral Resources, most of the area and nearby area consists of consolidated rock. This is triacid semi-metamorphic sedimentary rock is composed of green gravel forming a very thick layer along with shale, limestone, and gravel. Groundwater is trapped in the fissure, crack, and joints between the rock layers. The groundwater well information public on the website of the Department of Groundwater Resources that can be searching and download information for the website. The groundwater database and groundwater map of Department of Groundwater Resources public on The application Badan for Thai. We can search for groundwater well in the study area immediately, including download the report. This is the resistivity instrument for measurement composed of subsat SS10 model resistivity meter, 2 rows of cable, 4 hammer. The electrodes consist of 2 copper and 4 stainless steel, a set of vertical battery for a power source, 3 radio communication, geographic positional system, and a survey record form for field data recording. The electrical resistivity survey will be selected in different ways depending on the purpose of the survey. Venner array and Schlumberger array are commonly used in groundwater investigation. For Schlumberger array, looking at the depth of the groundwater exploration, the Venner array is able to explore both vertical and horizontal information in proposed not much deep length. The graphic shows the relationship between the electric current sent into the underground layer, different distance from the survey point. The electric current is transmitted through the different soil and rock layers, perform measurement and resistance and the voltage, to be calculated as the apparent resistivity at the distance from the survey point. Plot the graph to show the relationship between resistance and distance, as shown the graphic in the picture. The example in the picture, it is found that the electrical resistivity is calculated according to the distance from the survey point, to be plotted on the graph and able to interpret the geological layer according to the electrical resistance of three classes R1, R2, and R3. It was found that the resistance of R1 was higher than the resistance at R2, and the resistance of R2 was less than the resistance of R3. When the resistivity equipment is complete, the operator will read the electric current and voltage obtained from the instrument screen and take a note of the information in the survey form. Then the current electrode is moved along the survey distance, and the voltage electrode is moved by the survey distance as specified in the data recording survey form. The survey operation should have the staff to hammer electrode into the ground and move the survey point along the survey distance. At least one staff for the left and right on each side by the electrode were moved to the next survey point on both sides each same time and the same distance. This picture shows a geophysical survey in the field. The participation of teachers and students of the Salkeo College of Agriculture and Technology to studying learning and geophysical operating experience. The picture shows the survey data recording by weather configuration, which specific the survey distance of 20 meters and plot the resistivity curve of each value according to the survey distance of the survey point. The picture showed a record of survey data for each survey point by importing the data into computer program in order to prepare the data to be analyzed and interpreted in the next step. The picture shows the of the data processing and interpretation using appropriate software packages such as API2Win, R2D REST. This is an example of resistivity interpretation result for each point by using a package of computer program API2Win. An example of the geophysical survey interpretation for each survey point by referring to the electrical resistance according to international standard and interpret the geological classification by relying on basic geological and hydrogeological data of the survey area. The example of geophysical survey interpretation in the form of resistivity cross-section with reference to the electrical resistance according to international standard. The table shows of the electrical resistivity of igneous, metamorphic, and sedimentary rock. The summary of data analysis and interpretation of resistivity survey measurement to study soil and rock characteristics and shallow groundwater in Sa-Keo College of Agriculture and Technology. Survey date on 6 October 2020. This is the satellite imagery map showing the geophysicals in the survey area number 1. The resistivity survey line of survey area number 1 composed of 6 survey points with a distance of each the survey point of 20 meters. The exploration 20 meters of depth. The picture showed geological environment of the sediment and outcrop in survey area number 1. The summary of the geophysical survey result, data analysis and interpretation of the survey area number 1. And can be summarized the geological layer from the resistivity value from the survey. And the table shows summarize of data analysis and interpretation of resistivity survey measurement to study rock and soil type and shallow aquifer in the different the range of resistance. And the satellite imagery map showing the geophysical survey area number 2. The resistivity survey line of survey area number 2, a total of 9 points with a distance of each the survey point of 20 meters. Exploration depth 20 meters. The geological environment of sediment and outcrop in survey area number 2. The summary of the geophysical survey result, data analysis and interpretation of the survey area number 2. And we can summarize in table showing data analysis and interpretation. To classify rock and soil type and shallow aquifer for the different range of the resistance in study area number 2. And then we can to prepare final report of the geophysical survey for the project different. This is shows picture of the groundwater recharge pond before and after geophysical survey. The pond was designed and constructed for the open system of groundwater recharge pond. The original pond was 5 meters of depth. Dig the pond to the depth of 5 meters and found the water flow out from the shallow aquifer recharge into the pond. To increase flow meter of the water level below surface in the pond and the groundwater quality within the acceptable drinking water standard. Lastly, thanks to the lecture on geophysical survey and reference support information composed of Department of Mineral Resource, Department of Groundwater Resource, and Geo and Civil Service Company. Thank you for your attention.